Another example. The learning theory in psychology indicates that the performance rate of someone learning a skill is proportional to the difference between the maximum level of performance and its current performance. So what happens is, if you are starting to learn something new, you probably will learn it very fast. But as you already attain a certain amount of skills, it is going to slow down your performance rate at the end. So we are going to set up a differential equation. Typo. So here I'm going to follow the sentence. The performance rate of someone learning a skill is proportional to the difference between the maximum performance and its current performance. So this is my equation. And once I have the equation, I can now solve this differential equation. I can bring this to the left hand side. 1 over m minus p dp equals, multiply this dt to the right hand side and integrate both sides. Now keep in mind that the maximum level of performance, m, is a constant term because technically it shouldn't change. The maximum level of performance should always stay at, let's say, at 100%. So in this case, this is a constant. But as I integrate both sides, we will still end up with ln m minus p, and using chain rule, we have that negative coming out. On the other side, integrating this will give us kt plus c. And as I remove the negative and the long, m minus p will now end up with negative kt plus, and I got a constant. Well, let me call it constant, and then here comes with a base e. If you don't like using c1, you can keep it as minus c, but it basically wouldn't affect anything. And since we're talking about positive concept, I can simply remove the absolute value and have m minus p instead. And once again, as m is a constant, I can move this constant to the other side and single out the p at the end. Or in another word, as I bring the p to the other side, this will end up with m minus e to the negative kt minus c. Or, once again, similar to what we saw in example 1, e to the power of this will give us another constant, which makes it into something that you may find familiar with. Another constant, e to the negative kt. This constant isn't necessarily be the same as that constant, but you probably have seen something like this back in logarithm and exponent. Remember what you've done in logarithm, where you can actually calculate some accumulated value of a continuous growth functions using something like this. This part looks pretty much the same as that.